Chapter 1 of Book 3 of On the Heavens by Aristotle, translated by J. L. Stocks. This LibriVox recording is in the public domain. Recording by Geoffrey Edwards. Chapter 1. We have already discussed the first heaven and its parts, the moving stars within it, the matter of which these are composed, and their bodily constitution. And we have also shown that they are ungenerated and indestructible. Now, things that we call natural are either substances or functions and attributes of substances. As substances, I class the simple bodies, fire, earth, and the other terms of the series, and all things composed of them. For example, the heaven as a whole and its parts, animals again, and plants and their parts. By attributes and functions, I mean the movements of these, and of all other things in which they have power in themselves to cause movement, and also their alterations and reciprocal transformations. It is obvious, then, that the greater part of the inquiry into nature concerns bodies, for a natural substance is either a body or a thing which cannot come into existence without body and magnitude. This appears plainly from an analysis of the character of natural things, and equally from an inspection of the instances of inquiry into nature. Since then we have spoken of the primary element, of its bodily constitution, and of its freedom from destruction and generation, it remains to speak of the other two. In speaking of them, we shall be obliged also to inquire into generation and destruction. For if there is generation anywhere, it must be in these elements, and things composed of them. This is indeed the first question we have to ask. Is generation a fact or not? Earlier speculation was at variance both with itself and with the views here put forward as to the true answer to this question. Some removed generation and destruction from the world altogether. Nothing that is, they said, is generated or destroyed, and our conviction to the contrary is an illusion. So maintained the school of Melissus and Parmenides. But however excellent their theories may otherwise be, anyhow they cannot be held to speak as students of nature. There may be things not subject to generation or any kind of movement, but if so, they belong to another and a higher inquiry than the study of nature. They, however, had no idea of any form of being other than the substance of things perceived, and when they saw, what no one previously had seen, that there could be no knowledge or wisdom without some such unchanging entities, they naturally transferred what was true of them to things perceived. Others, perhaps intentionally, maintained precisely the contrary opinion to this. It had been asserted that everything in the world was subject to generation, and nothing was ungenerated, but that after being generated, some things remained indestructible, while the rest were again destroyed. This had been asserted in the first instance by Hesiod and his followers, but afterwards, outside his circle, by the earliest natural philosophers. But what these thinkers maintained was that all else has been generated and, as they said, quote, is flowing away, close quote, nothing having any solidity except one single thing which persists as the basis of all these transformations. So we may interpret the statements of Heraclitus of Ephesus and many others, and some subject all bodies whatever to generation by means of the composition and separation of planes. Discussion of the other views may be postponed, but this last theory, which composes every body of planes, is, as the most superficial observation shows, in many respects in plain contradiction with mathematics. It is, however, wrong to remove the foundations of a science unless you can replace them with others more convincing. And, secondly, the same theory, which composes solids of planes, presupposes planes of lines and lines of points, so that a part of a line need not be a line. This matter has been already considered in our discussion of movement, where we have shown that an indivisible length is impossible. But with respect to natural bodies, there are impossibilities involved in the view which asserts indivisible lines, which we may briefly consider at this point. For the impossible consequences which result from this view in the mathematical sphere will reproduce themselves when it is applied to physical bodies. But there will be difficulties in physics which are not present in mathematics. For mathematics deals with an abstract, and physics with a more concrete object. There are many attributes necessarily present in physical bodies, which are necessarily excluded by indivisibility. All attributes, in fact, which are divisible. There can be nothing divisible in an indivisible thing, but the attributes of bodies are all divisible in one of two ways. They are divisible into kinds, as color is divided into white and black, and they are divisible per accidens, when that which has them is divisible. In this latter sense, attributes which are simple are nevertheless divisible. Attributes of this kind will serve, therefore, to illustrate the impossibility of the view. It is impossible, if two parts of a thing have no weight, that the two together should have weight. But either all perceptible bodies, or some, such as earth and water, have weight, as these thinkers would themselves admit. Now, if the point has no weight, clearly the lines have not either, and if they have not, neither have the planes. Therefore, no body has weight. It is further manifest that their point cannot have weight, for while a heavy thing may always be heavier than something, and a light thing lighter than something, a thing which is heavier or lighter than something need not be itself heavy or light, just as a large thing is larger than others, but what is larger is not always large. A thing which, judged absolutely, is small may nonetheless be larger than other things. Whatever then is heavy, and also heavier than something else, must exceed this by something which is heavy. A heavy thing, therefore, is always divisible, but it is common ground that a point is indivisible. Again, suppose that what is heavy is a dense body, and what is light, rare. Dense differs from rare in containing more matter in the same cubic area. A point, then, if it may be heavy or light, may be dense or rare, but the dense is divisible, while a point is indivisible. And if what is heavy must be either hard or soft, an impossible consequence is easy to draw. For a thing is soft if its surface can be pressed in, hard if it cannot, and if it can be pressed in, it is divisible. Moreover, no weight can consist of parts not possessing weight. For how, except by the merest fiction, can they specify the number and character of the parts which will produce weight? And further, when one weight is greater than another, the difference is a third weight, from which it will follow that every indivisible part possesses weight. For suppose that a body of 4 points possesses weight. A body composed of more than 4 points will be superior in weight to it, a thing which has weight. But the difference between weight and weight must be a weight, as the difference between white and whiter is white. Here the difference which makes the superior weight heavier is the single point which remains when the common number 4 is subtracted. A single point, therefore, has weight. Further, to assume on the one hand that the planes can only be put in linear contact would be ridiculous. For, just as there are 2 ways of putting lines together, namely, end to end and side by side, so there must be 2 ways of putting planes together. Lines can be put together so that contact is linear by laying one along the other, though not by putting them end to end. But if, similarly, in when putting the planes together, superficial contact is allowed as an alternative to linear, that method will give them bodies which are not any element nor composed of elements. Again, if it is the number of planes in a body that makes one heavier than another, as the Timaeus explains, clearly the line and the point will have weight. For the three cases are, as we said before, analogous. But if the reason of differences of weight is not this, but rather the heaviness of earth and the lightness of fire, then some of the planes will be light and others heavy, which involves a similar distinction in the lines and the points. The earth plane, I mean, will be heavier than the fire plane. In general, the result is either that there is no magnitude at all, or that all magnitude could be done away with. For a point is to a line as a line is to a plane, and as a plane is to a body. Now, the various forms in passing into one another will each be resolved into its ultimate constituents. It might happen, therefore, that nothing existed except points, and that there was no body at all. A further consideration is that if time is similarly constituted, there would be, or might be, a time at which it was done away with. For the indivisible now is like a point in a line. The same consequences follow from composing the heaven of numbers, as some of the Pythagoreans do, who make all nature out of numbers. For natural bodies are manifestly endowed with weight and lightness, but an assemblage of units can neither be composed to form a body, nor possess weight. Chapter 2. The necessity that each of the simple bodies should have a natural movement may be shown as follows. They manifestly move, and if they have no proper movement, they must move by constraint, and the constrained is the same as the unnatural. Now, an unnatural movement presupposes a natural movement, which it contravenes, and which, however many the unnatural movements, is always one. For, naturally, a thing moves in one way, while its unnatural movements are manifold. The same may be shown from the fact of rest. Rest also must either be constrained or natural. Constrained in a place to which movement was constrained. Natural in a place, movement to which was natural. Now, manifestly, there is a body which is at rest at the center. If, then, this rest is natural to it, clearly, motion to this place is natural to it. If, on the other hand, its rest is constrained, what is hindering its motion? Something, perhaps, which is at rest. But, if so, we shall simply repeat the same argument, and either we shall come to an ultimate something to which rest, where it is natural, or we shall have an infinite process, which is impossible. The hindrance to its movement, then, we will suppose, is a moving thing, as Empedocles says that it is the vortex which keeps the earth still. But in that case we ask, where would it have moved to but for the vortex? It could not move infinitely, for to traverse an infinite is impossible, and impossibilities do not happen. So the moving thing must stop somewhere, and there rest, not by constraint, but naturally. But a natural rest proves a natural movement to the place of rest. Hence, Leucippus and Democritus, who say that the primary bodies are in perpetual movement in the void or infinite, may be asked to explain the manner of their motion, and the kind of movement which is natural to them. For if the various elements are constrained by one another to move as they do, each must still have a natural movement which the constrained contravenes, and the prime mover must cause motion not by constraint, but naturally. If there is no ultimate natural cause of movement, and each preceding term in the series is always moved by constraint, we shall have an infinite process. The same difficulty is involved even if it is supposed, as we read in the Timaeus, that before the ordered world was made, the elements moved without order. Their movement must have been due either to constraint or to their nature, and if their movement was natural, a moment's consideration shows that there was already an ordered world, for the prime mover must cause motion in virtue of its own natural movement, and the other bodies, moving without constraint, as they came to rest in their proper places, would fall into the order in which they now stand, the heavy bodies moving towards the center, and the light bodies away from it. But that is the order of their distribution in our world. There is a further question, too, which might be asked. Is it possible or impossible that bodies in unordered movement should combine in some cases into combinations like those of which bodies of nature's composing are composed? Such, I mean, as bones and flesh. Yet, this is what Empedocles asserts to have occurred under love. Quote, "Many a head," close quote, says he, quote, "came to birth without a neck," close quote. The answer to the view that there are infinite bodies moving in an infinite is that, if the cause of movement is single, they must move with a single motion, and therefore not without order. And if, on the other hand, the causes are of infinite variety, their motions too must be infinitely varied. For a finite number of causes would produce a kind of order, since absence of order is not proved by diversity of direction in motions. Indeed, in the world we know, not all bodies, but only bodies of the same kind, have a common goal of movement. Again, this orderly movement means in reality unnatural movement, since the order proper to perceptible things is their nature. And there is also absurdity and impossibility in the notion that the disorderly movement is infinitely continued, for the nature of things is the nature which most of them possess for most of the time. Thus, their view brings them into the contrary position, that disorder is natural, and order or system unnatural. But no natural fact can originate in chance. This is a point which Anaxagoras seems to have thoroughly grasped, for he starts his cosmogony from unmoved things. The others, it is true, make things collect together somehow before they try to produce motion and separation. But there is no sense in starting generation from an original state in which bodies are separated and in movement. Hence, Empedocles begins after the process ruled by love, for he could not have constructed the heaven by building it up out of bodies in separation, making them to combine by the power of love, since our world has its constituent elements in separation, and therefore presupposes a previous state of unity and combination. These arguments make it plain that every body has its natural movement, which is not constrained or contrary to its nature. We go on to show that there are certain bodies whose necessary impetus is that of weight and lightness. Of necessity, we assert, they must move, and a moved thing which has no natural impetus cannot move either towards or away from the center. Suppose a body A without weight, and a body B endowed with weight. Suppose the weightless body to move the distance C, D, while B in the same time moves the distance C, E, which will be greater since the heavy thing must move further. Let the heavy body then be divided in the proportion C, E, C, D. For there is no reason why a part of B should not stand in this relation to the whole. Now, if the whole moves the whole distance C, E, the part must in the same time move the distance C, D. A weightless body, therefore, and one which has weight, will move the same distance, which is impossible, and the same argument would fit the case of lightness. Again, a body which is in motion, but has neither weight nor lightness, must be moved by constraint, and must continue its constrained movement infinitely. For there will be a force which moves it, and the smaller and lighter a body is, the further will a given force move it. Now, let A the weightless body, be moved the distance c, e, and B, which has weight, be moved in the same time the distance c, d. Dividing the heavy body in the proportion c, e, c, d, we subtract from the heavy body a part which will in the same time move the distance c, e, since the whole moved c, d. For the relative speeds of the two bodies will be in inverse ratio to their respective sizes. Thus the weightless body will move the same distance as the heavy in the same time, but this is impossible. Hence, since the motion of the weightless body will cover a greater distance than any that is suggested, it will continue infinitely. It is therefore obvious that every body must have a definite weight or lightness. But since nature means a source of movement within the thing itself, while a force is a source of movement in something other than it, or in itself qua other, and since movement is always due either to nature or to constraint, movement, which is natural, as downward movement is to a stone, will be merely accelerated by an external force, while an unnatural movement will be due to the force alone. In either case, the air is, as it were, instrumental to the force. For air is both light and heavy, and thus, qua light produces upward motion, being propelled and set in motion by the force, and qua heavy produces a downward motion. In either case, the force transmits the movement to the body by first, as it were, impregnating the air. That is why a body, moved by constraint, continues to move when that which gave the impulse ceases to accompany it. Otherwise, i.e., if the air were not endowed with this function, constrained movement would be impossible, and the natural movement of a body may be helped on in the same way. This discussion suffices to show, 1. That all bodies are either light or heavy, and 2. How unnatural movement takes place. From what has been said earlier, it is plain that there cannot be generation either of everything or in an absolute sense of anything. It is impossible that everything should be generated unless an extracorporeal void is possible. For, assuming generation, the place which is to be occupied by that which is coming to be must have been previously occupied by void in which no body was. Now, it is quite possible for one body to be generated out of another, air for instance out of fire. But in the absence of any pre-existing mass, generation is impossible. That which is potentially a certain kind of body may, it is true, become such in actuality. But if the potential body was not already in actuality some other kind of body, the existence of an extracorporeal void must be admitted. Chapter 3. It remains to say what bodies are subject to generation and why. Since, in every case, knowledge depends on what is primary, and the elements are the primary constituents of bodies, we must ask which of such bodies are elements and why, and, after that, what is their number and character. The answer will be plain if we first explain what kind of substance an element is. An element, we take it, is a body into which other bodies may be analyzed, present in them potentially or in actuality. Which of these is still disputable, and not itself divisible into bodies different in form. That, or something like it, is what all men in every case mean by element. Now, if what we have described is an element, clearly there must be such bodies, for flesh and wood and all other similar bodies contain potentially fire and earth, since one sees these elements exuded from them, and, on the other hand, neither in potentiality nor in actuality does fire contain flesh or wood, or it would exude them. Similarly, even if there were only one elementary body, it would not contain them. For, though it will be either flesh or bone or something else, that does not at once show that it contained these in potentiality. The further question remains in what manner it becomes them. Now, Anaxagoras opposes Empedocles' view of the elements. Empedocles says that fire and earth and the related bodies are elementary bodies, of which all things are composed. But this Anaxagoras denies. His elements are the homeomerous things, viz., flesh, bone, and the like. Earth and fire are mixtures composed of them, and all the other seeds, each consisting of a collection of the homeomerous bodies, separately invisible. And that explains why from these two bodies all others are generated. To him, fire and ether are the same thing. But since every natural body has its proper movement, and movements are either simple or mixed in mixed bodies, and simple in simple, there must obviously be simple bodies, for there are simple movements. It is plain then that there are elements, and why. End of chapter 3. Recording in memory of Mitchell Edwards.